More robots are entering European manufacturing industries than ever before in history. Machines are becoming smarter and more capable, but the way we train people has not kept pace. We need new ideas. European researchers have spent 4 years working on one and found a solution in the virtual world. Extended reality is not a new invention, but combining it with safety tools, robot programming and interaction research into one complete training platform for industrial workers, that had rarely been done before. Until the European research project MASTER. The project is led by Panayotis Karagiannis at the University of Patras in Greece.
You create an environment like a video game and you put anyone that needs to learn something. And through this environment, it's easier to teach him what you want him to learn. He engages his senses, the touch, the audio, the vision. So it's not just reading, which is a kind of one-dimensional, let's say, approach. It's a whole experience.
To create this experience, 3 specific problems had to be solved. How people interact with machines, how anyone can program a robot without specialist knowledge, and how to build a virtual world that behaves like the real one. Research teams in 3 countries each took on one, starting with research into the human eye. In Saarbrücken, at the German Research Center for Artificial Intelligence, researcher Laszlo Kopacsi uses virtual reality headsets that have tiny cameras. They track precisely where the eyes are looking, the basis for what the team calls active gaze-based interaction.
Active gaze-based interaction when the user is explicitly using their eyes to interact with the system. So basically you look at something and then you have the intention to interact and then your gaze will trigger like an action, an interaction.
To find out how this gaze-based interaction works in practice, the researchers ask volunteers to carry out a simple task, sorting coloured balls. 3 methods are compared: controlling using only the eyes, using the eyes in combination with handheld controllers, and using controllers alone. Michael Bartz and Laszlo Kopacsi have turned eye-controlled interaction into a working toolkit. During assembly tasks, information about a component is displayed on the screen the moment the user looks at it. Objects can be selected and menus navigated using only the eyes.
Gaze-based interaction is different from traditional XR or virtual reality interaction methods. It adds another modality to the field. So the usual way to interact with XR or VR devices is either with your hands, with gesture recognition, or using controllers. And here you now have a second modality that might add more richness to the interaction and might make it more robust.
Making it easier to interact with machines is one part of the challenge. Ensuring people's safety is another. In Patras, Greece, the Laboratory for Manufacturing Systems and Automation has been working on this.
The new approach for safety systems is to use virtual zones. They have several benefits compared to static fences. We use the glasses in order for the operator to see where he can walk, where he is not allowed to walk. Another aspect of safety is ergonomy. So you can see inside the virtual environment how the operator is working, and you can see if he stresses his hand, his neck, or his back. So you can teach him that this is a good posture, this is a bad posture.
In a factory, a mistake is not just a learning moment. It can lead to serious injuries or worse. The team built tools that let trainers create virtual safety scenarios to teach operators where the dangers are, how to move safely, and what to do when a robot is nearby. Alongside safety, the project had another goal: making robot programming something anyone can actually do, not just engineers. This was the work of Johan Kildal and his team at Technica in the Basque Country.
Users will be able to indicate a new configuration for a robot by physically placing it in space in a different way. So they actually grab the physical robot and move it, or identically they grab the hologram and move it. And in that sense, you can transfer knowledge, skills, and you don't need to write any code.
In practice, it looks like this. A person using virtual reality equipment teaches a robot a task by simply demonstrating it. This is called programming by demonstrating. The volunteer picks something up, puts it down, and repeats the movement. The robot watches and learns. The platform that runs all of this was already waiting in Bilbao, also in the Basque Country. Virtualware had spent years building Viru, a commercial training platform already used in industry. The master research team used it as the foundation for all their developments. At the heart of it is the digital twin, a precise virtual copy of a real machine that looks, moves, and responds like the original. What operators learn on it transfers directly to the real machine. Here, inside a virtual wind turbine, each one is moving, interacting, and learning. Sergio Barrera is Chief Technical Officer at Virtualware.
Vira platform allows our customers to create their own contents, but abstracting the complexity of a system which is running across internet with a lot of users.
And crucially, mistakes have no real-world consequences. No damaged machines, no financial losses, and no injuries. Testing whether the technologies work in practice was the task of an independent institution based in Greece, the Teaching Factory Competence Centre. They presented complete training scenarios to students, teachers, and developers, and measured whether people genuinely learn from them. Konstantina Salagiani leads this work.
Using innovative and more intuitive technologies, the students can learn faster and better their training material. But simply introducing new technologies, trying to replace traditional methods, is not always sufficient. We need to find the appropriate combination and validate using certified methodologies applied on multiple working groups.
The results confirmed it works. More than 100 engineers, operators, and students took part in the tests. They rated the technologies as easy to use, robot configuration time fell, and safety awareness improved.
For me, the important aspect is what has been built, how we can push it forward, starting from the people that have already used it, but also people outside learn about it and give it a try. The feedback was positive, and already people say that they would like to use it in the future as well. I don't know if they will keep the promise, of course, but it's a good sign that it's something that has been well accepted.
Master supported 41 additional projects through 2 rounds of external funding, bringing the platform into new industrial sectors across Europe. What began as a research project to bridge the gap between humans and machines has resulted in a generation of workers who enter a virtual factory, learn at their own pace, and emerge ready for the real world.